Right. Shall we start then? If you're ready, we can work on this. What do you think? Do you think that we should try the energetics first or the organic chemistry I suggested? Shall we start with energetics? Question number 61, question number 6 up to 61 up to 60 we have discussed. So starting with question number 61, part 1, I'm not going to work on that because we have discussed that now several times. The heat liberated on neutralization of HCN and HClO4 by sodium hydroxide is 42.1 and 51. So if you take HCN and you add the potassium hydroxide to this, it gives you KCN and H2O. KCN and H2O. Now you know HCN is a weak acid. I gave you several rules how to identify acids, strong acids and weak acids. So this is a weak acid. Weak acid. The energy is plus 42 point, no, not plus minus 42.1 kilojoules per moles neutralization energy. And if you look at HClO4, HClO4 plus potassium hydroxide, you get KClO4 plus H2O. That is minus 51. What do they ask? How many kilojoules are absorbed ionizing H plus? So you know we talked about this last week also. This weak acid neutralization enthalpy is lower because it absorbs some amount of energy to break the bonds. So what is that amount of energy? If it is not there, because this is a strong acid, huh? ClO4 is not strong acid. Minus 51 minus 42.1. Right? What is that? Minus 51 plus 42.1. So 8.9. So minus 8.9, that amount of energy is absorbed. So since it is absorbed, we look at this as amount of energy absorbed. Amount of energy absorbed is actually plus 8.9. Because this will give you the difference. This will give you the difference. But 8.9 kilojoules are absorbed in order to ionize the weak acid. Let's see where there's a question here. Yeah, sodium hydroxide, potassium hydroxide, both are the same. They are both strong bases, right? Even sodium hydroxide, potassium hydroxide, this is a strong base. Neutralizing with potassium hydroxide, neutralizing with sodium hydroxide is the same, right? Because it's a strong base. Both are strong bases, equally strong. Right. Shall we try question number 62 then? Paranda, did you get those answers, Kila? The heat of formation of ethane and ethylene are this. Compute the delta H naught for the reaction of this. So this is C2H4 gas plus hydrogen gas giving you C2H6. Heats of formation of ethane and ethylene are this one. So we'll use a enthalpy cycle and try to work it out. Carbon, solid graphite, and then hydrogen. Because enthalpy of formation means you're forming starting from elements. 2 carbons here, hydrogen 4 plus 2 is 6, 3 hydrogens. C2H4 and the formation is there. C2H4 formation is minus 1410.9 kilojoules per moles. Right? And C2H6 is minus 1559 minus 1559.8 kilojoules per moles. So what is the enthalpy change here? Delta H. I think we can work it out, right? Minus 1410.9 plus delta HR is equal to minus 1559.8 kilojoules per moles. Delta HR is equal to minus 1559.8 plus 1410.9. Minus 148.9 minus 148.9 kilojoules per moles. Is it okay? Did you understand that? 65 karam balam. Abhi karam. Don't worry. We'll look at this, 62. Go with the 63, 64. Anybody want me to discuss that question number 63, 64? If you got those answers, can tell me. Right? Yes, did you get these answers or you want me to discuss them? Discuss 63. Karam. The enthalpy of combustion of C2H6, carbon, hydrogen, this one. Compute the formation of C2H6. C2H6 formation. Make a gas. So how do you form them? Using carbon, solid graphite, and then hydrogen. You balance the reaction first. 2 carbons. Hydrogen is 6 means 3 hydrogens. Enthalpy of combustion is given, right? And I think burn karam, make oxygen, you put oxygen to this side, put oxygen to this side. What do you get? You get carbon dioxide and you get water. This is what you get. Carbon dioxide, water liquid, 2 carbons. Hydrogen is 3. 2 times 4, 2, 4. 4 plus 3 is 7. 7 divided by 2. So here also 7 divided by 2. What's your name? So C2H6 combustion. What is that? C2H6 combustion is minus 1560. Minus 1560 kilojoules per moles. Carbon 393. Minus 393 times 2 kilojoules per moles. Hydrogen 286. 286 minus 286 times 3 kilojoules per moles. The delta HR. Delta HR minus 1560 is equal to minus 393 times 2 minus 286 times 3. What's right? Simple question within. Then now after doing 60 questions, these cannot be that difficult, right? Minus 393 times 2 minus 286 times 3 plus 1560. Here the minus 84 get now. Everybody got that? Right. Okay. 66 Karamu will first work on this in a sequential manner. 63 is that. 63. Go with the 64. 64. Anybody want me to discuss 64? No need. Kilakena. Is it okay? Do 65 Karamu. 65 Karamu is 63. Go with the Kila. 63 is okay. 63 is done. 64, 65, 64, 64. I think it's okay then. Everybody okay with that? 64. And 64th current only, right? Heat of combustion of carbon disulfide, carbon solid. It's like, now, no point doing this. 65 right? 65. It's like the same. Put it try. Right? 65 will do it. Right? 65. Calculate the formation of pent 3 in 19. Okay. So this is the structure of this. Sorry. Structure of this may double bond is there, like double bond, and then there's a triple bond here. So what this mean is this one is 1, 2, 3, 4, 5 carbons. First carbon is CH3. Second carbon is CH, double bond CH. Then you have C triple bond CH. This is the first carbon, this is the second carbon, this is the third carbon, this is the fourth carbon, this is the fifth carbon. First carbon. Second and third, you have a double bond. Fourth and fifth, you have a triple bond. Now you balance the valencies with hydrogens. That's all, right? So reaction of if delta H sublimation carbon and bond dissociation energies are these ones for this one, delta H formation. Formation is given, like, this is they ask you to calculate the formation, carbon, solid, graphite. And then you have hydrogen also, but I don't know whether data is missing. Carbon 1, 2, 3, 4, 5. You need 5 carbons. How many hydrogens? 3, 4, 5, 6. That means 3 hydrogens. So this is enthalpy of formation. This is enthalpy of formation. It's what is called enthalpy of formation. Carbon sublimation, solid graphite sublimation is given 715 carbon gas. This is hydrogen. Hydrogen also gas. How many hydrogens? 6 hydrogens. 5 carbons. But this one here gives you 715 times 5. Sublimation. This is sublimation. But under hydrogen bond dissociation enthalpy, do you find it? Find the hydrogen bond dissociation enthalpy. Carbon, hydrogen, carbon, triple bond, 432 for hydrogen, 432 for hydrogen, 432. So 432 times 3 kilojoules per mole. Right. Now let us break this one. We need to break carbon hydrogens. How many carbon hydrogens? 1, 2, 3, 4, 5, 6. Carbon hydrogens you have to break. So 413 for carbon hydrogens. 413 times 6. Plus another. Carbon single bonds. This is a single bond. This is a single bond. How many carbon single bonds? Carbon single bond is 346. 346 times 2. Plus, what is the next one? Double bond. Carbon double bond is 611. One double bond, 611. Triple bond, one triple bond, 837. And for this one, right? Okay, so delta HF plus 413 times 6. 346 times 2. 611. 837 is equal to 715 times 5 plus 432 times 3 kilojoules per mole. Delta HF. Calculate 715 times 5 plus 432 times 3 minus 413 times 6 minus 346 times 2 minus 611 minus 837. 253 kila. 200, I don't know, plus 200. Let me double check that. Okay. Delta HF, subtract that. Is equal to this. About double check. You also double check. 715 times 5. 715 is Yeah, bond make a sublimation, right? 5, 1, 2, 3, 4, 5. Hydrogen 3, 4, 5, 6. That means 3 hydrogens. Put 715 times 5 plus 432 times 3. Right. Minus 413 times 6. Minus 346 times 2. Minus 611 minus 837. 253 kilojoules per moles. Even though it says 945. Anybody got those answers? 253 is confirmed. Okay. That is 253 is the answer. Now, many of you have got 253. Right? So I'll correct the answer there, right? 253. Is it plus 253? Plus 253. That is okay. Na? Question number 65 then. 65 is a maybe problem with the answer, right? 253. Right? All of you have got 253 according to those who have written answers. Right. Okay. Hi. Okay. This is question number 66. Did you try that? 65. So answer in the tube is wrong. Right? Right. Okay. Which one? Question number 66. Right. Question number 66 also will do that. It says, calculate the delta H formation of MgCl3 if these values are given, right? So if I look at this now, it doesn't say do it with using energy diagram. I can do it using a cycle also, but if you feel like you want to do it in an energy diagram, tell me, right? So magnesium solid and then chlorine Cl2 3 divided by 2 gives you MgCl3. This is your diagram, right? Magnesium sublimation, magnesium gas, magnesium gas sublimation is 146 kilojoules per mole. Then what you can do is you can get magnesium plus 1 gas. What is magnesium plus 1? First ionization energy 738 kilojoules per mole. 738. Magnesium plus 2. Magnesium 2 plus means second ionization energy 1450 kilojoules per mole. Magnesium plus 2 goes to magnesium plus 3. Magnesium plus 2 goes to magnesium plus 3, 7800 kilojoules per mole. Right. Okay, yeah, right. Then let us look at chlorine. Chlorine, you have to convert it to chlorine atoms. Cl gas. How many atoms? 3 atoms. What is the energy? Chlorine dissociation is 242. 242 multiplied by 2, multiplied by 3 divided by 2. Right? Kilojoules per moles. Right. The bus say electron gain affinity or electron gain enthalpy is given. Na? It's electron gain actually. Even though it says EA, minus value is electron gain. Chloride, 3 chloride gas minus 364 multiplied by 3 kilojoules per moles. The quota and lattice energy is given minus 5,800. The delta H reaction. How do you get the delta H reaction? Delta H reaction is equal to 146, 738, 1,450, 7,800 plus 242 times 3 divided by 2 minus 364 times 3 minus 5,800 kilojoules per moles. 146, 738, 1,450 plus 7,800 plus 242 multiplied by 3 divided by 2 minus 364 times 3 minus 5,800. That is also, I don't know, 3,605 then. Kilojoules per moles. What did you get? 306. Okay. Yes. 3,605. Okay. You got that? In a 1,447 for magnesium. I2. I2 is 1,000. I2. Like, there's a, in the bottom, there's a 1,450. Right? Not 1,405. So second column, last one, that is the data that I have taken. 1,000, say 3,605. So answers. But you understood the method, ne? Right. Okay. Yeah. Yeah, two values are given. Common, I think it's like a difference of 3 units with I. 3 with I Venus. Won't we divide again the bond dissociation of chlorine by 2 again? The one mole of bonds. One bond dissociation is the amount of energy to break 1 mole of bonds. So you are using 3 divided by 2 moles. So that is 3 divided by 2. So multiply by 3, divide by 2. I became better. Right? Are yeah. Right. That was question number 66. Come with the question number 67. Did you try that out? 67? Question number 67? I don't know. Next one is 68. No need of 67. It is easy. How about the others? Can you do question 67? Question number 67 also will do. 67. Consider the following bond enthalpy data. Assume that the enthalpy of vaporization of benzene is negligible. Calculate the delta HF using 2 different methods. Bond dissociation enthalpy using the combustion data. Right. Formation, solid, graphite, plus hydrogen. Yes. And you get benzene, C6, H6, liquid, right. The 6 carbons, hydrogen is 3 hydrogens. So what do they ask? They ask you to calculate using the bond dissociation. Let us use the combustion data. And then if you look at this, you get CO2 plus H2O. H2O is liquid, right? Burn it in the presence of oxygen. Burn it in the presence of oxygen. 6 carbons, hydrogen, 6 can 3. 15 divided by 2. This is also 15 divided by 2. No, right? Okay. Sublimation enthalpy of carbon, combustion of carbon is 393. So minus 393 times 6 plus minus 393 plus times 6 plus hydrogen combustion is 286 minus 286 times 3 kilojoules per moles. Benzene combustion data is 3170. 3170 kilojoules per moles. Delta H formation. Delta H formation minus 3170 is equal to minus 393 times 6 minus 286 times 3 kilojoules per moles. What is delta HF? Delta HF is equal to how much? Minus 393 times 6 minus 286 times 3 plus 3170. So at, what is the value? Minus 393 times 6 minus 286 times 3 plus 3170. So minus 46 kilo. 46 kilojoules per moles. Using combustion data, we use combustion data to do this calculation. Then they ask you use the bond dissociation enthalpy to do this. Solid graphite plus hydrogen gas giving you benzene. Carbon, 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 and then you have carbon, carbon, carbon. Double bonds, double bonds, double bonds. And you have hydrogens. Enthalpy of vaporization is negligible. This is a liquid. 6 carbons, 3 hydrogens. Right. Carbon in the gas phase. 6 hydrogens in the gas phase. 6 carbons. Carbon solid graphite, carbon gas. Sublimation of carbon 715. 715 times 6 kilojoules per moles. Hydrogen bond dissociation is given 436. So 436 times 3 kilojoules per moles. What is the other one? Other one you get carbon hydrogen bonds 416. 416 times 6 plus. Then you have carbon carbon single bond. Carbon carbon single bond is 358 times 3. Then you have a carbon carbon double bond 691. 691 times 3 kilojoules per moles. So let us say this is delta H R. What is delta HR? Delta HR plus 416 times 6. 358 times 3. 691 times 3 is equal to 715 times 6. 436 times 3. delta HR, 715 times 6 plus 436 times 3 minus 416 times 6 minus 358 times 3 minus 691 times 3. Minus 45 here. 45 kilojoules per mole. What is the answer given? Bond dissociation enthalpy 45. That answer is right. Something has changed. Right? That's okay. Na? Everybody understood that? Right. Okay. That was question number 67. Right? 67, 66, 65. That, yeah. Right. Okay. Now what is the next one? 68. I thought somebody said 68 also. Right. So let us do 68 as well. 68. Question number 68. Let's do that. The reaction of hydrogenation of acetylene C2H2 proceeds according to this. This reaction is given C2H2 gas plus 2 hydrogen gas giving you C2H6 gas. Calculate the delta H for the reaction using the following data. The combustion. So let us burn it. Right? Both sides, let us burn it. Let us burn it with oxygen. And then this one is also with oxygen. And that gives you carbon dioxide and H2O. How many carbons? 2 carbons, so 2 carbon dioxide. Hydrogen, 2 times 2, 4 plus 2 is 6. That is 3 hydrogens. 2 times 2, 4 plus 3 is 6, 7. 7 divided by 2. This is also 7 divided by 2. And that will give you carbon dioxide. This gives you water. This also gives you combustion, right? C2H2 combustion is given, right? So 2 moles, 2599. Here you are burning 1 mole. So that is 2599 divided by 2 kilojoules per mole. Minus, right? C2H6. 2 moles, 3119. This is 3119 divided by 2 kilojoules per mole. Hydrogen, 2 hydrogen plus oxygen, water. That is for 2 moles of 572. I hope I am right. Delta HR. So what is the reaction? Delta HR minus 3119 divided by 2 is equal to 2599 divided by 2 minus 572 kilojoules per mole. What is delta HR? Minus 2599 divided by 2 minus 572 minus. This is plus 3119 divided by 2. 312 Kelvin minus 312 kilojoules per moles. 624, I think it is been calculated to 2 moles. Okay, double calculate color again. Right? That is why. Because it is for 1 mole here. This is 1 mole. That is why. That is wrong. This should be 312. Did you get the point? Why did the value differ by 1 kilojoules per moles? Where? Which one? Earlier one. You think it depends because you are using the average bond dissociation enthalpies. They are not the real bond dissociation enthalpies. average bond dissociation enthalpies. How did you directly got 572 to the cycle? You think there's hydrogen plus oxygen to water. That is for 2 moles of hydrogen. So 2 moles of hydrogen. So this is 2 moles that you are burning. So 572 minus 572. That value is directly added. Is it clear? Right? But sometimes, these answers might be, there's a little bit of a issue with these answers. They may double check without tutorials answers, right? Okay, so you have to be like most of them are right, but then sometimes you have right? Everybody okay? Now somebody said 312. Any other thought? Any parts that you didn't understand there? Anything? Anything you want me to explain again? Question number 68. Then 669. Did you try? 69. Did you all try? 69, question number 69. Kian Balan, what is going on? When heated cautiously, ammonium nitrate turns into N2O and water. Remember, we wrote that reaction. Ammonium nitrate turns into N2O and water, right? So it says ammonium nitrate, NH4NO3, solid, turns into N2O and water. N2O is a neutral gas plus water. This is the reaction. Formation of these and calculate the delta H for the decomposition. So nitrogen is there, oxygen is there, and then hydrogen is also there. Nitrogen, 2 nitrogens, oxygen 3 divided by 2. Hydrogen 4 can 2. So ammonium nitrate formation. Ammonium nitrate formation is 368 minus 368 kilojoules per moles. Formation of N2O is 82. This one is 82 minus 82 kilojoules per moles. Water 286. There's 2 moles of water. 286 times 2. The delta H reaction. So delta H reaction minus 368 is equal to minus 82 minus 286 times 2. Unit is kilojoules per moles. So what is the delta HR reaction? What is that value? Minus 82 minus 286 times 2 plus 368. 240. 286. Answer is given. 286 kilojoules per moles. No. That is 200. Let me double check. Is that the answer you got? Minus 82. Minus 82 minus 286 times 2 plus 368. Yeah, 286 is what I get. Really? Yeah, this is what you get. Calculate the total heat evolved when the reaction take place, 1 kilogram of ammonium nitrate. So, number of moles of ammonium nitrate. What happens suddenly? Right. So, if you look at this one, the delta H is 286. So number of moles of ammonium nitrate. What is the number of moles of ammonium nitrate? 1 kilogram, that means 1000 grams. Divide by nitrogen. Nitrogen is 14, 14, 28. Hydrogen is 4. 16 times 3, 80 grams per moles. Grams and grams cancels, 8 cancels out. 100 divided by 8 is equal to 12.5. So 1 mole, this amount of energy. Na? So total energy is equal to minus 286 multiplied by 12.5 kilojoules. 286 times 12.5. 3575 is the amount of energy. 3575. 75 kilojoules. Did you get that? Oh. Formation is 368. N2O formation is 82. Right? Water formation is 286 times 2. I didn't do anything wrong. Ne? The stupid mistake. 68, 82. Remember, I double check that. 82 minus 286 times 2 plus 368. 286, I think that is right. Plus 82 then. Yes, plus 82. Ne? That's the thing. Okay. Right. Okay. 82 minus 286 times 2 minus 368. 82 minus 286 times 2 plus 368. 122. I think that is right. 122 is right. My mistake. Yeah. Minus 122. That's a right thing. What you have to multiply this also by 122. 122 times 12.5. 1525. Energy is released. So this should be not minus, plus 82. That is right. The question is right. The answer is right. What I did was wrong. Question number 70. How did the question number 70 goes? Yeah. Right. Okay. I saw this just now. Right. All your answers. Sorry. Question number 70. How? How is it working? Right. Thank you. Thank you. Positive. Yes. My mistake. Positive. Positive. Yes. Question number 70. Question number 70. How does it work? Question number 7. One might think that we could react SO2 with oxygen to produce SO3. But this reaction does not occur readily. Instead, the following two steps sequence may be used to produce SO3. Right? This reaction. Use these two reactions to determine the enthalpy of formation of the reaction of SO2 with oxygen to form SO3. Then, using delta H SO2, calculate the delta H formation of SO3. Is the reaction endothermic or exothermic? Right. Look at what you have is, you have NO gas plus half oxygen giving you NO2. No, that's the first reaction. That is minus 57.2 kilojoules per moles. This is kilojoules per moles, not just kilojoules. Kilojoules per moles. Correct. And the next one is NO2 plus SO2 giving NO plus SO3 is equal to minus 41.7 kilojoules per moles. Use these two reactions to determine the enthalpy of formation of sulfur dioxide with oxygen to form SO3. Enthalpy formation for the reaction of sulfur dioxide. The main reaction, like sulfur dioxide gas plus oxygen giving SO3. We are being asked to calculate this enthalpy change. This is half. No reaction. How do you do this? You look at the first reaction, look at the second reaction. If you take these two reactions, add them together, 1 plus 2. What do you get? NO gas, half oxygen. NO2 gas, SO2 gas. Giving you NO2 gas, NO gas, and SO3 gas. Right. NO and NO cancels out. NO2 cancels out, and then you get what you want to get. If you look at this reaction, it is SO2 gas plus half oxygen giving SO3. So this is our target reaction. If you want to get the enthalpies, you get addition of these two enthalpies. Add them together. Minus 57.2 minus 41.7. Addition plus minus means minus kilojoules per moles. Add them together. You get the reaction by adding them together. Enthalpy change also minus by adding together. 0.5 minus 41.7. Here then 98.9 kilo endole. Okay. Minus 98.9 kilojoules per moles. Right? Then using the delta H formation for sulfur dioxide is 399. Calculate the delta H formation for sulfur trioxide. So you have SO2 and then you have half oxygen giving you SO3. Enthalpy of formation of sulfur dioxide is 399. That means sulfur solid rhombic plus oxygen gas. The 3 divided by 2 sulfur. So sulfur dioxide you get using 399. 399 kilojoules per moles. Sulfur dioxide. Calculate the enthalpy of formation of sulfur trioxide. This is the enthalpy of formation of sulfur trioxide. This enthalpy you know minus 98.9 kilojoules per moles. So what is the enthalpy of formation? Enthalpy of formation is equal to minus 399 minus 98.9 kilojoules per moles. Then sulfur, 1 oxygen, 3 oxygens. What is the answer? Minus 399 minus 98.9. 497.8. Minus 497.8 kilojoules per moles. Formation is that. What is given is double the amount. Something. But then this is the value. Minus 399 and 98.9. Did you get those values? 497.9. Okay. Right. Everybody okay with that? Minus 122. Okay. Everybody okay? 97.8. This is, I have to update some of these answers actually. 497.8. Okay, so that was 70. Oh, the 71. How is question number 71? Did you do? Question number 71? So haven't done up to that point. Okay. You got that answer, eh? Very good, good. Right. So shall we do it then next time? From, yeah, okay. So question number 71 to 80. Can you try? Next week? Next week, question number 71 to 80. Right. Now we will go to the organic nomenclature part. Let me check what are the other things that you say. Okay, right. So, ඕනේ පුළුවන් තරමක් කරන්න. Right? මේ 71 to 90 කරත් කමන්නේ. No problem. පුළුවන් තරම් කරන්න. Right? Right. Okay. Good. Good, good. Right. So now we will move on to the organic part. Organic nomenclature. I actually received many questions over the week asking for nomenclature, the problems associated with this. So let us try to work that out. I think this is the first page of the tutorial. Now I have what I have done is this is the same tutorial, but I haven't given enough space for you to write the answer. I think that's why I said write it in a separate sheet of paper, right? So let us see whether I can work on this, right? Okay, shall we do this one? Make it, right? So how do you name this? So you have to identify the longest continuous carbon chain. What is the longest continuous carbon chain? Longest continuous carbon chain is this part. Okay. Only that is the longest continuous carbon chain. So the numbering 1, 2, 3, 4. 1, 2, 3, 4. Right? I think this is the best numbering. 1, 2, 3, 4. 5, 6, 7, 8, 9, and 10. Can you tell me what are the names? You have a ethyl, methyl, right? So what is the name that you can suggest? What is the name that you can suggest? 5-ethyl. 5-ethyl. According to the alphabetical order, this is 5-ethyl, right? Then you get 4, 5, 6 trimethyl. 4, 5, 6 trimethyl. Trimethyl what? Trimethyl decay. Right? 5-ethyl, 4, 5, 6 trimethyl decay is the answer. Everybody okay with that? Yeah, right. Yeah. Any questions? Sir, what if we write 465? 465 කියලා ලියන්න නෑනේ. 456 it's the order. දැන් ඔයා ලිව්වොත් එහෙම 465 කියලා. You don't get any marks. එකක්වත් නෑ, වැරදි, completely wrong. 456. Right? Did you understand that? Right? Okay. Right. Try the next one. Tut is uploaded to the website. Right? Only thing is this one I have put little bit of spaces. That's all. I gave you the tutorial last time. This is the next one. This is the next one. This carbon chain. right? This is the carbon chain. And then it goes into this side also, right? Okay, so 1, 2, 3, 4. 1, 2, 3. I think you can number it from this side. 1, 2, 3, 4, 5, 6, 7. Can you balance what is the name? What is the name? 4-ethyl, ned? Right? 4-ethyl. You have to give the lowest numbers to this one. 4-ethyl. What else? 4-ethyl. 4-ethyl. What? 4-ethyl. 3, 3, 4. 3, 3, 4. Trimethyl. Trimethyl. What? Heptane. බලන්න හරිද කියලා. Questions you have to ask. What if we don't take the longest possible check, but take the remaining as the propyl chain? It is still wrong. It's wrong. It is IUPAC නැත්නම් IUPAC නෑ. They have given some rules. We can't create our own rules. IUPAC rule එකට you have to go abide by the IUPAC rule. Right? When we need to go in the alphabetical order when writing, do we always, yeah, substitutions are named according to the alphabetical order. ඒක මේ මම කියන එක නෙවෙයි. I am not saying that. It's a IUPAC rule. දැන් අපි මම නම් කියන්නේ you I can okay ඔයා ඕන එකක් කරන්න I will be okay කියලා කියන්න පුළුවන්. But I am not the one who is saying this. මේ IUPAC rule නේ. So you have to go with the IUPAC rule. 4-ethyl. මේකේ ඉරක් ගහන්න ඕනේ පුතා. 4-ethyl. dash 334 dash trimethyl no space heptane. ඔක්කොම එකට ලියන්න ඕනේ. Right? Now some of you have typed it පොඩ්ඩක් අර වැරදි. ඒක පොඩ්ඩක් බලන්න. I don't know whether you read the 4-ethyl 334 methyl නෙවෙයි. 334 trimethyl වෙන්න. heptane. Right? Right. Okay. කමන්නේ. It's okay. අපි මේවා කරනවා ගොඩ කාලයක්. Don't worry. You will be pros at it. බය වෙන්න එපා. Right. So what is the longest continuous carbon chain? 1, 2, 3, 4, 5, 6, 7, 8, 9. And මේක නේද ගන්න ඕනේ. This one. Longest continuous carbon chain is that. හරිද? So 1, 2, 3, 4. මේක 1, 2, 3. මෙහෙන් එන්න ඕනේ නේද? 1, 2, 3, 4, 5, 6, 7, 8, 9. කියන්න බලන්න. Mama, what is this? So 4, 5, 5. නේද? 4, 5, 5. 4, 5, 5. Tri-ethyl. 4, 5, 5 tri-ethyl. 3, 6, 6. 3, 6, 6. Trimethyl. Methyl nonane. බලන්න හරිද කියලා. Nonane. බලන්න, okay. Right. Tell me whether you are okay with that. This molecule. How can we identify the longest carbon chain? Because all look the same. All look the longest carbon chain means you count the number of carbon atoms. How could you just count the number starting from a terminal and you go to the other terminal and count the number of carbon atoms? The maximum number is the longest continuous carbon chain. If there are multiple number of carbon atoms, then what you have is you have greater number of substitutions given. So searching dash take time, so I just neglected. Hurry. As long as you are writing it in the paper, I don't mind. No problem. 4, 5, 5 triethyl, 3, 6, 6 trimethyl nonane. Right. Everybody okay? ඒ තුන මොනවද තියෙනවද? Any questions? හරි. හදිසියක් නැහැ. We don't have to finish the entire tutorial today. First we need to understand how to do this. After that, it will be okay. Right? In IUPAC names, organic or inorganic can't be used capital letters. Usually, they don't use capital letters. Yeah, unless it is included in a sentence. So how that 366 කොහොමද ආවේ කියලා අහනවා. 36 කියලා කියන්නේ මෙතන 3 මේ this third carbon you have a methyl group. 6 carbon also you have the first methyl, second methyl. That is why you get 366 CH3. හරිද ඒක? Clear? Right. අපි බලමු මේක. Right, try this one. Right. Longest continuous carbon chain. බලන්න එහෙනම් මෙහෙම පටන් ගන්න මේ 1 2 3 4 5 6 7 8 1 2 3 4 5 6 7 8 දැන් ඔයාට now there are two chains නේ ඔන්න this is the first chain that you can come up with ඔය එකක් or else you can come up with this chain starting from this and you can go to that that is another chain that you can come up with. So now you have two similar chains. Then the rule is highest number of substitutions. So look at the blue line. How many substitutions are there? What are the substitution? When you look at the blue line, this substitution is there. This substitution is there. Then there are only two substitutions. If you look at the pink line, may substitution there are three substitutions. So you go for the pink line. Longest continuous carbon chain is this. This is the longest continuous carbon chain is this. Or my parent chain. Did you understand that? If the same number of if the same chain length is there, you need to look at the greater number of substitutions. Ethyl ලියනකොට ETHYL E එකක් නැහැ. Methyl no E at the end. හරිද? Somebody has written it everywhere. හරිද? ඒක හොඳයි. I'm very appreciative about your දාන මේ effort එකට. Right? You are typing all the commas ඔක්කොම දානවා. හැබැයි one letter wrong, entire name is wrong. You know, it's like your name when you write a wrong letter. Right? So it's like that. How do you number it? 1, 2, 3. This is 4, 5, 6, 7, 8. What is the name? So propyl, ethyl, 4 ethyl. Whatever. 4 ethyl. Let me take this. 4 ethyl. This part. 4 ethyl. What else? 4 ethyl. A, B, C, D, F, G, H, I, J, K, L, M. 3 methyl. 3 methyl. M, E, T, H, Y, L. E එකක් නැහැ. Right? Did you understand that? 4 ethyl, 3 methyl. Then 4 propyl. 4 propyl. Octane. No space, no gaps, nothing. හරිද තේරුණාද? Right? 4 ethyl, 3 methyl, 4 propyl octane. 4 ethyl, 3 methyl, 4 propyl octane. In case if the blue carbon chain has the highest number of blue carbon chain has a higher number of substitutions and IC we consider it's their name for that substitution group apart from ethyl group. There are methods of doing them. They are not in our syllabus. Right? There is a method. Within syllabus syllabus rules. Let's look at it. Otherwise, it will be very complex. UPSC rules කියලා පොතක් තියෙනවා වෙනම. red book and a blue book. එහෙම තියෙනවා. ඉතින් එතකොට ඒ ඔක්කොම rules ගන්න බෑනේ. අපිට ඕනේ rules ටික අපි ගමු. Right? With time, I will teach you one by one. Right? Things, how things are. දැනට මේක මෙහෙම කරන්නකො. දැනට මෙහෙම කරන්න. ඉස්සෙල්ලා මේ ටික පොඩ්ඩක් we master it. This is the longest continuous carbon chain. ටක් ගාලා කියන නම. Right? 1, 2, make a 1, this is 2, this is 3, this is 4, this is 5, this is 6. What is the name? Taggala dan baran. What is the name? So 3-ethyl, 2,3 dimethyl, මොකද්ද? Dimethyl hexane. බලන්න හරිද කියලා. 3-ethyl, 2,3-dimethyl hexane, right? Some of you write that. How propyl came? කොතෙන්ද පුතා propyl ආවේ? කොතෙන්ද propyl ආවේ? Earlier one. Propyl කියලා කියන්නේ ඉතින් this 3 carbons නේ. This is called propyl. 3 carbons is called propyl. Propyl is the substitution. Harith, did you understand that? Will the whole answer be wrong if there is a capital letter? Capital letters na liyanna. Sometimes I have seen this even in the paper, they have written capital letters. Normally, as for my knowledge, they don't write capital letters. Right? Okay, so what is this one? Then this is definitely, you are sure, no, this one is the longest continuous carbon chain is this. My longest continuous carbon chain is that. Number correct? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. MNOP. එනම් මෙතිල් මෙතින් එන්න ඕනේ මේ 1 2 3 4 5 methyl 6 7 8 9 10. If the same number is given, you give the priority to the substitutions, alphabetical order. මොනවද ඒ කරන්නේ? MNOP. එතකොට what is the name? 5,5,6 trimethyl. Trimethyl එකේ M එක තමයි බලන්නේ. You are looking at the M, not tri. Tri means 3 na. The actual name is methyl. Trimethyl. මේක ethyl එක නේද? methyl propyl නෙවෙයි. MNOP A B C D E F නේද? This is, I need to correct it. MNOP A B C D නේ නම් මේන් එන්න ඕනේ. This side මේ පැත්තෙන් එන්න ඕනේ. 1 2 3 4 5 6 7 8 9 10. So 5-ethyl, you have an ethyl. I thought it's a propyl. Ethyl. Ethyl, and then 5,6,6 trimethyl decane. දැක්කද? 5-ethyl 5,6,6 trimethyl decane. බලන්න හරිද කියලා. Everybody okay? Right. Okay, good. So that is this answer. This one is this answer. Right, okay. Right, this one. Right, let us identify the longest continuous carbon chain. 1, 2, 3, 4, 5, 6, 7. That's the longest continuous carbon chain. Number 1, 2, 3. 1 2 3 4. මේන් තමයි better number. 1 2 3 4, 5, 6, 7. Okay. 3, 4 diethyl. Diethyl heptane. 3, 4 diethyl heptane. බලන්න හරිද කියලා? Good. දැන් හරි නේද? shape එක යනවනේ. Right. Try the next one. මේක හරි නම් let's do the next one. Next one is this longest continuous carbon chain. බලන්න 1 2 3 6 7 8 9 1 2 3 4 5 6 7 8 9. Anything is okay, right? Okay, so now let us number it. 1 2 3 4. 1 2 3 4. This is propyl, this is ethyl. So you have to number it from this side. 1 2 3 4 5 6 7 8 9. What is the answer? 4 ethyl. 5, 6 dipropyl. Propyl. Nonane. බලන්න හරිද කියලා? Check whether this is okay. 4 ethyl, 5 6 dipropyl nonane. Everybody okay? Then last one නෙවෙයි, under that, this is the longest continuous carbon chain. 1 2 3, that is called 3 ethyl pentane. 3 ethyl pentane. Are there any questions here? Six ethyl 4 5 නෙවෙයි. 4 ethyl 5 6 dipropyl nonane. Right? You have to give the alphabetical order the priority. Because from both sides you get the same number. Na? From this side, from the right hand side also you get 4 5 6. From the left hand side also you get 4 5 6. Then you are getting the same number from both sides. Then you go for the alphabetical order. හරිද? ඔයා ලියලා තියෙනක වැරදි ඒක. Septane නෙවෙයි. Heptane. Septane කියන්නේ. Yeah. හරි නේද? Anything that you want to clarify? Yeah. හරිද? Yeah. When the numbering shouldn't propyl group get the priority and the ethyl group, since it has 3 carbon atoms, එහෙම නෙවෙයි. the alphabetical order එකට priority එක දෙන්නේ. ඔයා හිතන ඒවට නෙවෙයි. They give the, I'm not saying anything bad, මම මේ නිකන් ජොලියට කිව්වේ. It's the alphabetical order. It doesn't matter how many chain length. UPSC අය දැනට දීලා තියෙන rule එක තමයි. You go for the alphabetical order. එච්චරයි. Right? හරිද? Right? Clear? එහෙම අපිට ඕනේ rule එක දාන්න බෑ. Right? UPSC එක දානකොට you go for the alphabetical order. That is what they have said. Right? Okay. Let's do this one also. බලන්න මේක පොඩ්ඩක් පුළුවන්ද කියලා බලන්න. Right. Let's try that. හරිද? Okay. Right. So let's look at this one. කොහොමද බලන්න? How does it work? Right. Okay. So what is the longest continuous carbon chain? Longest continuous carbon chain is this. Okay? 1 2 3 4 5 6 7 8. 1 2 3 4 5 6 7 8. There are 8 carbon atoms, but you go for the highest number of substitutions. Right. So now numbering. 1 2 3. 1 2 3 4. So you have to number it from this side. Right. Okay. So give me a name. Just to clarify, if there is a propyl group and a methyl group and a ethyl group, numbering should be done by prioritizing the first ethyl. නෑ පුතා එහෙම නෙවෙයි. I gave you the list of rules. ඔයා පළවෙනිටම බලන්න ඕනේ the numbers, numbering for the substitutions. So you have to give the lowest numbers for the substitutions as much as possible. That's the first rule. If the numbers are the same for all the substitutions, then you go for the alphabetical order. බලන්න රූල් මම දීපු නෝට් එකේ ලියලා තියෙනවා. Then and only then you go for the alphabetical order. If the numbers are the same. First you go for the lowest number of substitutions. Right? Right. So what is the thing? Ethyl, propyl, the methyl, right? So we have ethyl 4,5,5 triethyl. මේක හරි මෙයා හරි මෙයා හරි. ඒ methyl 3-methyl. මෙයා හරි. Then 4-propyl. Propyl octane. බලන්න හරිද කියලා? Is it clear? මොනවද ලියලා තියෙන්නේ? Triethyl තමයි තියෙන්නේ. Triethyl 2, 3, anyway 4, 5, 5. I don't know whether this is the same question. It's like the same question we are looking at. Make a this is how you name it. Right? Clear? Triethyl, 3-methyl, 4-propyl octane. Propyl octane. No, not two words. No spaces. Samara very, there are places where you apply spaces. This is not a place where you apply. You can't have any spaces in it. There are specific places where you can apply spaces. Everything is one word, no capital letters. No space. No space. Clear? Right. Aniket Balan. So let us look at the longest continuous carbon chain. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Right. So this is your name. Right. So now let us number it. 1, 2, 3, 4. 1, 2, 3, 4. Common number kera tekai. So you can start numbering from this. 1, 2, 3, 4, 5, 6, 7. Right. You want to make it. Now when you have something like that, this is not called propyl. Propyl means CH2, CH2, CH3. Make it a propyl again. This is propyl. Now it is connected from the center. It is not called propyl. Make it a number. There's a separate rule. Like from the connection, you look at the longest continuous carbon chain. And then you number it 1, 2. Or what is this? Methyl, ethyl. So this group is called ethyl. What is that? 4-ethyl. Terunani? 4-ethyl. That part. In the fourth position, you have 1-methyl, and heptane. Right? The 4-ethyl you understood me. 4-ethyl you understood. In the 4th position you have a ethyl group. This is that part. 4-ethyl. In the 4th position you have another ethyl group. You have two carbon atoms. But in the first position, you have a methyl group. So in the fourth position, you have one methyl. This is that methyl part. This green color one is ethyl part and heptane. Right? 4-ethyl, 4,1-methyl ethyl heptane. Right? That's how you name it. Sir, after 4, shouldn't it be a comma? After letter and a word and a letter is separated by a hyphen. Comma danna. Right? Word and a letter is separated by a hyphen. There's a bracket, so it should be separated by a hyphen. Why can't this be the main chain? Count what is the main chain? Why can't this be the main chain? 1, 2, 3, 4, 5, 6. Longest continuous carbon chain is 7. So cannot be the main chain. When writing the methyl ethyl, do we consider the alphabetical order? Oh, ethyl comes first, methyl comes later. Right. Okay. So what is the longest continuous carbon chain? See how that is going to work. 1, 2, 3, 4, 5, 6, 7, 8. I think this is the longest continuous carbon. So let's name them. Let's number it. 1, 2 ne 1, 2, 3, 4, 5, 6, 7, 8. Okay. Can you tell me the name? What is the name? You have 4-ethyl. 4-ethyl. What else? 2, 3, 3, 4. 2, 3, 3, 4. Tetramethyl octane. Tetramethyl octane. Tetramethyl octane. Isn't ethyl is C2H5. C2H5 tamai ethyl. Yes, C2H5 is ethyl. Ethyl is C2H5. CH3, CH2, C2H5 කියන්නේ එකයි. C2H5 means you have two carbon atoms. Here you have a hydrogen, you have a hydrogen and a hydrogen. And there is another hydrogen and a hydrogen. That group is called C2H5. When you write C2H5, that is what you mean by that. Just for clarification, how much time will you take for finish organ? I will take a little bit of time. How fast can you understand? Question, right? I can do it when but can you understand and then remember it? We'll do it. Doesn't matter. That is my clarification for you. Right? I hate when people ask when I am going to finish it, when I am going to finish it. Right? We always want to start. And then as soon as we start, we want to finish it. It's not installing a program. Right? Okay. Only thing is, Mama iti Vilatina, I'm a very slow teacher. You are fast learners. I am a slow teacher. And I think maybe we are not compatible. Right. Okay. ඊළඟ එක මොකක්ද? කීවෙනි එකද පුතා? Which one? Which one? How do you get 4 ethyl can කීවෙනි එකද? The earlier question. Immediate earlier question. කීවෙනි එකද? Why did you take CH3CH as ethyl in the previous question? මේකද? This one. ඉතින් ඒකේ chain length එක 2. 2 carbon is ethyl එකට එන්නේ. That is why it's not just ethyl. It's one methyl ethyl. ඒකේ methyl එකක් තියෙනවා. methyl. ඒ don't worry වැඩි worry වෙන්න එපා දැනට. දැනට ඔම worry වෙන්නේ නැතුව ඔම කරන් යන්න. මම ඒ වගේ ආයෙ එනකොට ඒවට ආයෙ බලමු. Right, okay. Right, Ken. What is the next one? Did you try this one? What is the longest continuous carbon chain? 1, 2, 3, 4, 5, 6, 7, 8, 9. I think that is the longest continuous carbon chain. But anything longer than that? 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. That is the longest continuous carbon chain. Right? What is the numbering? Where should we start numbering? 1, 2, 3, 4. 1, 2, 3, 3. 1, 2, 3, 4. I think this is better. Na? 1, 2, 3. This is 4, 4. 5, 5, 6, 7, 8, 9. බලන්න හරිද කියලා. Right? Focus on this. Focus on this. ඉස්සල්ල එක බැරි වුණා නම් don't worry. ඒක ගැන worry වෙන්න එපා. Now look at focus on this one. Right? Did you understand the numbering? මම ඔන්න අනිත් පැත්තට number කරන්නම්. Right? This is 1, 2, 3, 4, 5, 6, 7, 8, 9. If you look at the blue numbering, let us look at the purple numbering. Those substitutions are given the number 4, 5, 6, 6. If you look at the blue numbering, you get 4, 4, 5, 6. What is the better numbering? 4, 4, 5, 6 or 4, 5, 6, 6? What is the better numbering? According to the IUPAC rule, you have to give lower numbers possible to the substitutions. Therefore, this numbering is bad. This is the best number. So that is why we number it from this side. So I will remove these ones. Otherwise, what will happen is we will make mistakes there. Right. Okay. So what is the name? What is the name? Let us say 4, 4, 6. 4, 4, 4, 6 triethyl. 4, 4, 6 triethyl. MNOP. 5 methyl. What else? 5 propyl. No name. Right? 4, 4, 6 triethyl, 5 methyl, 5 propyl, no name. Is it clear? Everybody understood that? 4, 4, 6 triethyl, 5 methyl, 5 propyl, no name. Is it correct? It is correct. Right. 5 propyl, 5 no name. Are everybody okay with that? Question number 13. 4, 4, 6 triethyl, 5-methyl, 5-propyl, nonane. Kiyවෙන එකද පුතා ඔය? You're talking about this question. මේක වෙන්නේ ඔය තාම කතා කරන්නේ නේද? Which question are we talking about? Why can't we get the principal chain like this? You are still here. තාම අතීතේ ඉන්න හදන්නේ. ඉතින් මේක very simple thing නේ. You can't get the principal chain නේ. ඔයා මට කියන්නකෝ කෝකද ලොකු කියලා. Which one is bigger? Like if you take this as the principal chain, ඕම බලන්න. Right, I will give you a මෙන්න මේ වගේ එකක් අපි ගත්තොත් එහෙම මේක. You are thinking you are thinking this kind of color. මේ color එකෙන් තමයි principal chain එක is this. ඔයා කියනවා මේක තමයි principal chain එක කියලා. බලන්නකො number එක ගණන් කරන්න. 1 2 3 4 5 6. දැන් මට කියන්න ඔයා පොඩි කාලේ ඉගෙන ගත්තේ 6ද ලොකුද 7ද ලොකු? Which one is bigger? 6 or 7? එතකොට 7 තියෙනකොට 6 එක principal chain එක කියලා ගන්න බෑ. It's violating the IUPAC rule. Right. So that is not the principal chain. It is not the principal chain. Right? It is not the principal chain. හරිද? එතකොට ඔයාගේ priority එක identify කරන්න ඕනේ. First thing is you identify the principal chain right. Principal chain එක නැති කරලා වෙන එකකට යන්න බෑ. That is wrong. Once the principal chain is there, it was say if there are 2 carbon chains with the same principal number of carbon atoms, then you go for the highest number of substitutions. If the highest number of substitutions are there, then you go for the lowest number of numbers, lowest number. If the numbers are the same, you go for the alphabetical order. Then you can't violate and go for the alphabetical order. Right? So there's a kind of a priority. A priority I gave you in sequence rules right? A rules follow right? So you can't go for 6 ignoring 7. Shape. That's okay. Right. Balan, now let's look at this one. This question, try this one. What is this? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the longest continuous carbon chain. Number karan? 1, 2, 1, 2, 3, 4. 1, 2, 3, 4. There are 2 substitutions. 1, 2, 3, 4, 5, 6, 7, 8, 9. Can you give me a name? Name for this. What is the name? Ethyl, the 4-ethyl. What else? 4-ethyl. This part is there. It was saying MnOP 4,6 dimethyl. 5-propyl. No name. But 4-ethyl, 4,6 dimethyl, 5-propyl, no name. Everybody okay with that? Right. 4-ethyl, 4,6 dimethyl, 5-propyl, no name will be the answer. Yes. Okay, good. You are correct. Right. Methyl, lethal, right? Yeah, don't worry. Don't worry about that for the moment. Then me anik tika karannu. ඊට පස්සේ අපි simple things we will fine tune. Tava making ඉවර නැහැ. Like until you end organic chemistry we have nomenclature. Right? Okay. Right? This is the first time, so don't worry. Worry වෙන්න එපා. මේ තේරෙන ටික ඉස්සලා කරන්නකො. Right? Okay. So what is the next one? Right, okay. That is the longest continuous carbon chain. Mama, I will send you this document. Don't worry. You can go through it. I will take it as the last question. Then maybe 1, 2. Like get me this right. 1, 2. Yes, 3, 4, 5, 6, 7. What is the name? Can you tell me what is the name? What is that? 4-ethyl. ඊට පස්සේ 2, 3, 4. 2, 3, 4 trimethyl heptane. බලන්න හරිද කියලා? Did you get that answer? O-ethyl 2, 3, 4 trimethyl heptane. මේක බලන්න. මේකත් අපි ඉවර කරමු. What is the name? 1, 2, 3, 4 1, 2, 3, 4. මොකක්ද ඒක? O-ethyl 1, 2, 3, 4 5, 6, 7. Hept. බලන්න හරිද? O-ethyl ETHYL ethyl heptane. Right. එහෙනම් මේ ටිකත් ඉවර කරමුද? These three things also. ඒකට හොඳයි නේද? ඒකට like we can start from a different page නේ. 1, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. ඒ both are the same, right? ඒක මොනවත් වෙනසක් නැහැ. I think you get the same name from both sides. 1, 2, 3, 4. 1, 2, 3, 4. එතිල්ලුක් තියෙනවනේ. එහෙනම් මේන් we'll number it from this side. 4, 5, 6, 7, 8. කියන number 4-ethyl. ඊට පස්සේ 4, 5 dipropyl octane. O-ethyl 4, 5 dipropyl octane. තව එකක් කරන්න මේකත් කරන්න. right ටික ගාලා කරන්න දාන්න. මේක නේද? Longest continuous carbon chain is this. What is the name? 1, 2, 3. 1, 2 නේ මෙහෙන් දාමු නේද? 1, 2, 3, 4, 5, 6. මොනවද දෙන්නේ? 2, 3, 4 trimethyl hexane. Check whether you get that answer. 2, 3, 4 trimethyl hexane. You are getting it right. Very good. දැන් ඉතින් ටික ටික හොඳට තියෙනවා. Is it compulsory to highlight the number the carbon chain while answering the paper? එහෙම ඕනේ නැහැ පුතා. මේක ඉතින් දැන් I'm just telling you how to work it out නේ. එහෙම එකක් නැහැ. You write the name. ඔයාගේ නම ලියන්න ගියාම නම ලියන්න එච්චරයි. අය ඔයාව අදින්න ඕනේ නැහැ. It's like that. නේද? එහෙම එකක් නැහැනේ. Right. Okay. What is this one? 1, 2, 3, 4, 5, 6, 7, 8, 9 නේද? එහෙම දාමු නේද? This is the chain නේ. බලන්න තියෙනවද කියලා anything bigger than that? 1, 2, 3, 4, 5, 6, 7, 8, 9. ඔක්කොම 9 තමයි නේ. Right. Okay. So let's get the chain length 1, 2, 3. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. How do you name this? 3, 4, 5 triethyl. 4-methyl. No name. හරිද? 3, 4, 5 triethyl, 4-methyl, no name. That's all. 3, 4, 5 triethyl, 4-methyl, no name. Good. Okay, very good. What is it? Right. Methyl, no name. Right. Okay. In RNA, right. Okay, so there we will stop for today. You see now that is the second page. Balamu api, like you try the material. We will look at the next Saturday when we meet. I will do some questions and we'll continue with the material. Right? Okay. ठीक है करा तो don't worry, I will make sure you become better at it. Why Vendepa? Yeah, Vendepa, right? Okay. Good. So that is enough for today. Right. Thank you for being with me. Right. We will meet next Saturday. Right. Bye. Good night.